In this video, we are going to talk about some of the properties and definitions of trapezoids, as well as special types of trapezoids. The first thing I want to say is that there are competing definitions of what a trapezoid is. For our purposes, we will talk about trapezoids as quadrilaterals that have exactly one pair of parallel sides. And remember, this is our symbol for parallel. Some mathematicians, instead of using the word exactly, will use at least one pair, but that then also includes all of our parallelograms that we've already learned about. For this class, we are going to choose to use the definition of exactly one pair of parallel sides. So we could show that on our figure with those little arrows. Those arrows show us that the sides are parallel. Now, our two parallel sides are what we call our bases. You notice that they are both called a base because I could just as easily flip this trapezoid over like that, and it would still be a trapezoid, and it would still be sitting on its base. So we have our two bases. We are going to call these sides legs, which you'll notice is also the same term that is used for isosceles triangles. So in a trapezoid, we also have legs that are connecting our two bases. Now let's think for a moment about this trapezoid. I have two parallel lines, and if I were to say extend this leg and extend those parallel lines, these are actually our parallel lines cut by a transversal. So we know that these two angles here, which I could label A and B, are actually same side interior angles. So we could say that the same side angles, well, what do we know about same side angles in parallel lines cut by a transversal? They are supplementary. Which means that they add up to 180 degrees. So we now know that there is one pair of parallel sides, and we know that these angles add up to 180 degrees. That also means that those angles add up to 180 degrees. The last thing that we know has to do with the line right here. This line is our midsegment. The midsegment, and we can make a note over here of what a midsegment is. It connects the midpoints of the two legs. So this is congruent to this is congruent to this. And you notice that I did not show that those two legs were congruent to each other. In a trapezoid, they do not have to be congruent to each other. And our midsegment has a property. The midsegment is equal to the average of the two bases. So if you add up the lengths of the two bases and divide by 2, that will give you the length of the midsegment. And those are our three properties of trapezoids. Now, trapezoids do have two special types that we want to consider. Our first special type is going to look like this. You notice that I still have a pair of parallel sides that are my bases, but that one of my legs is perpendicular to the base. That is what we will call a right trapezoid because it has two right angles. So we could say that one leg is perpendicular to the base. You notice I do not say that two legs are perpendicular. If that was the case, we could look at it like this. If this was perpendicular, we would just have a rectangle. And we are going with the definition that trapezoids are not types of parallelograms. So that's why a right trapezoid is only going to have one leg perpendicular to the base. I do want you guys to notice that I could just have easily drawn my right trapezoid like that. It still has exactly one pair of parallel sides, so it is still a right trapezoid. Our last special trapezoid we want to talk about is going to be called an isosceles trapezoid. Let's think of what that word isosceles means. When we think of isosceles triangles, we have two congruent sides. We can also have that in a trapezoid, where my two legs are congruent to each other. So we know that both legs are congruent. Now let's consider what that is going to mean for our figure. It means that these two halves of it are symmetric. So we know that these angles are congruent and these angles are congruent. We are going to call that the base angles are congruent. So in that case, those are my base angles. These are also base angles. So those two angles that are on the same base, we'll call our base angles. The last thing we want to consider are our diagonals. And let's look at the two triangles formed by those diagonals. The first triangle is right here, 1, 2, 3. Now we notice that it has this side, it also has this side, and it has the angle in between, which I labeled with a B. If I look at the other big triangle, it's got this side, which we defined is congruent to the other leg. It's got that top base, which by the reflexive property is congruent to itself, and it also has an angle with angle B. Well, those two triangles are congruent to each other by side angle side. So we just used our side angle side congruence theorem. So we actually can prove then that this last side of the triangle must be congruent to each other. So we know that our diagonals are congruent. And those are our properties of trapezoids. You want to be careful because these properties listed here are only true in isosceles trapezoids. In other figures, they are not true. In a right trapezoid, you know that those two angles are clearly not congruent to each other. The last thing I want to point out in this video is that you can see it here, and we've done this before, where you can actually drop that height from one base to another, and you're creating right triangles. So in a trapezoid, you can create right triangles. That's great because then we can use the Pythagorean theorem, special right triangles, or trig to find out more about different parts of our trapezoids. Thank you very much. In the next video, we are going to do some examples where we make calculations in our trapezoids.